In this tutorial, you will use a custom tool and learn how to iterate a construction. First, you'll set up your tool folder and construct a right triangle. Next, you'll use your square tool from the previous tutorial to construct squares on the sides of the right triangle. You'll measure their areas and demonstrate the Pythagorean theorem. Finally, you'll learn to iterate the Pythagorean construction to make a fractal called a Pythagorean tree. You'll see how to add branches to the tree and how to remove them. Before we start investigating the Pythagorean theorem, let's set up our tool folder so that when it comes time to construct squares on the side of a right triangle, our square tool is ready to go. So to begin, open a new sketch and hold the custom tool icon. If the last command in the menu is choose tool folder, choose this command and designate a folder, or add a new one, as your tool folder. Leave this box checked and click choose. So now, press and hold the custom tool icon. Move the cursor to Example Tools in the Tool Folder section of the menu. You'll see a set of custom tools that come with Sketchpad. You'll use the Square tool in this tutorial. For those of you who have done Tutorial 8, Square Constructions, you have another option. Remember, in that tutorial, you made your own square tools. So if you want to use those, simply save your sketch into the tool folder and you'll have easy access to them. Now to begin investigating the Pythagorean theorem, you'll construct a right triangle to start, just as you did in Tutorial 2, Properties of Shapes. So choose the segment tool and construct a segment. Use the text tool to label its endpoints as A and B. With the arrow tool, select the segment and endpoint A and choose Construct Perpendicular Line. Now choose the point tool and move directly over the line and click to place the point. Label this point as C. To continue, select the line and choose Display Hide Perpendicular Line. All that now remains to do is to connect the 3 points with segments. Your triangle is now complete. When you drag any of its 3 vertices, you'll change the triangle's size and shape, but the triangle always maintains a right angle. To continue with my investigation of the Pythagorean theorem, I'll construct squares on the 3 sides of triangle ABC. To make the squares, I'll use my custom square tool. I'll press and hold on the custom tools icon and choose Square. Now I'll move back onto my sketch and I'll construct my first square on side AB. I'll click on point B, move my mouse, and attach the other vertex of this square to point A by clicking directly on the point. There I have my square. Next, I'll make a square that sits on side AC of my triangle. I'll click on point A and then on point C. Finally, I'll click on point B and point C to make my next square. But oh, that square points in the wrong direction. It overlaps the triangle. I'd really like it to point outward. To undo this mistake, I'll go to Edit and choose Undo Square. When I made this square, I clicked first on point B and then on point C, but that made the square point in the wrong way. Instead, I'm going to click first on point C and then on point B. Now my square faces the correct direction. The Pythagorean theorem says that if I add together the areas of the 2 squares sitting on the legs of triangle ABC, it will be equal to the area of the square sitting on the hypotenuse. I can use Sketchpad to help check this out. I'll select all 3 squares and go to the Measure menu and choose Areas. All 3 areas appear. To continue, I'd like to add together the areas of the 2 squares sitting on the legs. To do so, I'll use Sketchpad's calculator. I'll choose Number, Calculate, and the calculator appears. To enter the area measurements into my calculation, I'll click directly on the measurements in my sketch. I'll click on the area measurement of the square sitting on one leg, click plus, and I'll click on the area measurement of the other square sitting on a leg. Now I'll click OK. Notice that the sum of those two areas is equal to the area of the square sitting on the hypotenuse. If I drag point B, all of my area measurements change, but the sum of the areas of the two squares sitting on the legs of triangle ABC is always equal to the area of the square sitting on the hypotenuse. This isn't a proof of the Pythagorean theorem, but it does provide very strong empirical evidence. You can use the text tool to write a statement about the Pythagorean theorem directly in your sketch, and you can use hot text to insert the names of your squares into your statement. I've just gone through a series of steps to construct squares on the three sides of right triangle ABC. The image of these squares in the triangle is a classic representation of the Pythagorean theorem. Now I'm going to use this image as a starting point to construct a very beautiful object known as a Pythagorean tree. The branches of my tree will sprout out from these two squares sitting on the legs of the triangle. My tree will consist of many right triangles, all with squares sitting on their sides. To build this tree, I'll use a process known as iteration. To iterate an action is to repeat it some number of times. In geometry, an iteration uses an operation performed on one set of geometric objects to produce a new set of objects that share the same relationship. Let's see how I can use iteration to make my tree. First, I'll get myself a new page. I'll go to File, Document Options, and add a blank page. On my new page, I'll construct a square using my Square custom tool. I'll construct the square so that the 2 points that control the square's size sit on the bottom. Now I'll label the square's vertices. My goal now is to construct a right triangle with a hypotenuse of CD. I'm going to go through several steps to make this triangle. To begin, I'll select segment CD and choose Construct Midpoint. I'll label this midpoint as E. Next, I'm going to construct a circle with center at point E passing through point C. I'll choose the arrow tool, and I'll click in white space to deselect everything. Then I'll select point E, the center of my circle, and point C, where the circle will pass through. I'll choose Construct, Circle by Center and Point. My circle appears. My goal in constructing the circle was to use it in building an arc that sits on side CD of the square. To make the arc, I'll click in white space to deselect everything, and then click in order on points C, D, and the circle itself. I'll choose Construct, Arc on Circle, and there's my arc. I no longer need to see my circle, so I'll click just on the circle and choose Display, Hide Circle. Now that I have my arc, my next step, and I'm almost there with the right triangle, so just hold tight, is to construct a point on the arc. I'll choose the Point tool, and I'll click directly on the arc to place a point. I'll label that point as F, and I'll connect it with segments to points D and C. If I now drag point F, I get a whole collection of triangles. Can you explain why they're right triangles? I no longer need the arc or point E to be visible. I'll select them both and choose Display, Hide Objects. Now I just have a right triangle FDC and a square sitting on its hypotenuse. My square and right triangle are set, so I'm ready to iterate. I'll click on points A and B to select them, and then choose Transform, Iterate. Now I'll click on point D to map point A to point D, and point F to map point B to point F. When I do, I obtain the first branch of my Pythagorean tree. So what's going on here? What does this relate to in terms of iteration? Well, you can think about it this way. We started by constructing a square. That square was based on side AB. After making the square, we constructed a right triangle on the opposite side. So when I map A to D and B to F, what I'm really telling Sketchpad to do is to repeat this entire construction again, only starting with segment DF. In other words, build a square on DF, and then on the opposite side of that square, construct a right triangle. This process continues, through iteration, 2 more times. We have another square and right triangle, and another square and right triangle. Now I'm going to add another branch to the tree. I'll choose Structure, Add New Map. This time I'll map point A to point F and point B to point C. Here now we have more branches of our tree. Finally, I'll click Iterate. To experiment with my tree, I can do several things. First, I'll drag point F. This waves the branches of my tree back and forth. I also might want to add more branches to my tree so it really does look more like a tree. To do this, I'll click anywhere on my iterated images. Then I'll press the plus key on my keyboard. By pressing it repeatedly, I get more and more branches, and this looks more and more like a tree. If I want to remove branches, I just press the minus key.